Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Counting Renbans by Mimic, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits on a purple Renban line must be a set of consecutive, non-repeating digits in any order. Interesting. So that means on any line, so this is one line here. This must form a set of consecutive digits in any order, non-repeating. So this could be something along the lines of, say, 7, 6, 3, 8, 5, and 4. And this would be valid, because this forms a set of the digits 3 through 8, which are all consecutive. We could not, though, have something like, say, 9 here, because this would not be consecutive then. 3, 4, 5, 6, 7, 9 is not consecutive. And we could not have something like, say, 8 and 7 here, if this were 5, because we have a repeat on this Renban line, which is not allowed. And a purple circle indicates exactly how many circles contain that digit. For example, if there's a 4 in any circle, then exactly 4 4s contain a 4. So if this were, say, a 4, we would have to have 4 4s in these circles. So you could have that, and that would be valid, because you have 4 4s in those circles. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's count how many circles we have. We have 1, 2, 3, 4, 5, 6, plus 5 is 11, 12, 13, 14, 15, 16, 17, 18. We have 18 circles. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, so all the digits in circles must add up to 18, because each digit appears that many times in a circle, right? So 4 would appear 4 times, 1 would appear 1 time, etc., etc. And we know there are 5 distinct digits. So this has to be, so these cannot repeat, because we have at least 5 distinct digits, because in row 5 we have digits in circles, and they are all distinct, and that's 5 of them. So we have 5 digits adding up to 18. It could be 1, 2, 3, 4, 8, 1, 2, 3, 5, 7, 1, 2, 4, 5, 6. And I think those are all the possibilities, right? Is that true? 1, 2, 3, 4, 5. 1, 2, 3, 4, 8. 1, 2, 3, 5, 7. No, 1, 2, 3, 6, 6. If we have not 3 in it, 1, 2, 4, 5, 6. Can we have not 2? No. 1, 3, 4, 5, 6 is 19. So we know these have to be 1 through 8 here. And we are guaranteed 1 has to be one of these, and 2 has to be one of these. So we're guaranteed 1 and 2. 1 cannot appear in another circle because 1 already appears once in row 5. 2 does have to appear in a circle, though. So we could, again... So the remaining digits in this row have to be 3 through 9. Okay. Where is 5 in any Renban that is 5 in length? It has to be on the Renban. So we're guaranteed a 5 in one of these 5 cells. We're guaranteed a 5 in one of these cells here. We are guaranteed a 5 in one of these cells here, and we're guaranteed a 5 in one of those cells there. Also, what are we guaranteed for if it's size 6? Size 6 can be 1 through 6, 2 through 7, 3 through 8, 4 through 9, and those are the possibilities. So we're guaranteed 4 and 6 on this Renban, and here. So we're guaranteed 4, 5, and 6 on this Renban. These have to be consecutive. 1, 2, 3, 4, 8 requires this to be 1, 2, 3 or 2, 3, 4. So we cannot have 8 here. 1, 2, 3, 5, 7 requires 1, 2, 3 to be here. So it cannot be 5 or 7. We can't have... And 1, 2, 4, 5, 6 has to be 4, 5, 6. Interesting. Okay. 1, 2, 3, 4, 8 means this is 2 and 3 here. Oh, that doesn't work. Okay. Can we ever have 2, 3, 4 here? I think the answer is no. If we have 2, 3, 4 here, one of these is going to have to be a 1. And the problem with that is that 1 would have to be with 2 and 3 to form a Renban, to form a 3-length Renban. But the 2, 3, 4 here eliminates 2 and 3 in the rest of the row. So this one, whichever one is here, can't be with 2 or 3. Okay. So if this is 1, 2, 3, 4, 8, this has to be 2 here, with this being a 1, 3 pair. And then we have 4 and 8 here at the ends. 1, 2, 3, 5, 7 has the same thing. It's 2 here with 1 and 3. And then this becomes 5, 7. And then 1, 2, 4, 5, 6. Obviously 1, 2, 3 can't be here. That doesn't work. Because if we have 4, 5, 6 here, the problem is that we have to have 1 and 2 on the ends. And 1 can only be with 2 and 3 on a 3-length Renban. And obviously this couldn't be 1 and 2 here, because we'd have 1 and 2 in one of the possibilities here, but this could be 3. But then the problem is this 3, 4, 5, 6 eliminates 3, 4, 5, 6 in the rest of the row, so the 2 doesn't form with a Renban that way. So this is guaranteed to be a 2. We have a 1, 3 pair here. That eliminates 3 in the rest of the row. And this is can't be 1, 2, or 3. So it's 1, 2, 3 with either 4 and 8, 5 and or 5 and 7. Okay. This can only go down to 3 here and 3 here at best. So we have 3 through 9 here because we can only have 4 and 5 there. 3 here is also possible. If we have 8, uh, 8 is possible. So remaining digits in box 5 have to be 4 through 9. This has to be 4, 5, 7, or 8 here. And these are 4 through 9. We have to have a 2 somewhere. Hmm. Um... Hmm. This can only go... Okay, the digits in circles can never be 1. So we have in the circles, we can't have 6 or 9. So the digits in circles cannot be 6 or 9, cannot contain a 1. So they have to be 2, 3, 4, 5, 7, 8. So obviously 6 cannot be here. 6 can't be here because 6 cannot be on the circles. 6 can't be here. So where is the 6 on this Renban line? It must be one of these 4 digits here, which eliminates 6 in the rest of the column. So 6 on this Renban line can't be here. It has to be one of these 3. Okay. Hmm. 2 eliminates 2 as a possibility here. So this can't be 2. This can't be 2 either because of 2 in the column. Hmm. 5 and 7. Huh. Hmm. Four and 8. Hmm. So one of these 2 digits is here, right? This cannot be 8. If this were 8, this would guarantee this is 4. 4 and 8 do not form a Renban. So this can't be 8. This also can't be 4 either. right? If this is 4, that would force this to be 8, and again, that doesn't form a valid Renban. So if this is 4 and 8, it must be with 3. But that's not going to work, right? Because then this has the same problem. If this is 8, this would be 4. That would be 4 and 8 trying to be on a 3-length Renban, which doesn't work. If this is 4, that's 8. So it's the same problem. And then you would have to have one of these 3 be with an 8 to be on this Renban, which doesn't work. So this has to be 3, 4, 1, 2, 3, 5, 7. So we only have 3, 5, and 7 on these Renbans. That's interesting. So no 4 and 8s. Obviously this can't be 4. This can't be 4. No 4 here. No 4 there. 5, 7 eliminates 5, 7. The 5, 7 pair in row 5 eliminates 5, 7 in the rest of the row. We can only have these be 3 or 5 here. So 5, 7, and 5, 7 would have to have a 6 in between. And 3 with 5 could only have a 4 in between. So this becomes a 4, 6 pair, which eliminates 4 and 6 in the rest of the box. This is there, then, or sorry, rest of the row. So this is 8 or 9. That can only form a Renban, 3-length Renban with 7. So this is guaranteed to be 7. This cannot be 7 here. We are guaranteed 4 has to be one of these digits, so this can't be 4 here. 4 has to be one of these 3 digits here, and so does 6. 7 has to be, therefore one of these is guaranteed to be 8. It could be 6 or 8 or 9 here. One of these is 8. This is 7. This can't be 4 or 8 here. No 4 or 8 here. It has to be... What are the possibilities here? One of these is going to have to be a 3. We don't know which. So one of those is a 3. Because it has to form a 3-length Renban with 4 and 5. So that means which... This is, if this is 3, this is 5. Hmm. 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 We do know in each of these Renbans, 5 has to be somewhere there. So this is guaranteed to have a 5. That's guaranteed to have a 5. Ah, we have a guaranteed 5 in this Renban here, because it's either 1 through 5, 2 through 6, 3 through 7, 4 through 8, or 5 through 9, all of which require 5. One of these has to have a 5, because it's either this is 5, 6, 7, or it's 3, 4, 5. So where is the 5 in column 3? 5 cannot be here because of the 5 on the Renban. 5 can't be here because 5 has to be one of these two to fulfill that Renban. So 5 cannot be any of these digits here. So this is guaranteed to be 2 or 3. 5 has to be one of these two. So we're guaranteed one of these 3 digits on this Renban is a 5, which eliminates 5 from being here. So one of these two is a 5. Hmm. Um, this can be at best at least a 2. And it could be 2 through 9 there. So we need a 5 in one of these 4 cells. Because we cannot have any non-5s here. So therefore that eliminates 9 from the rest of this Renban. Because, again, if we tried not to have a 5 here, how does that work? This is 3 and 7. That's not a 4-length Renban possible from that. So we're guaranteed we have to have a 5 on... actually, I think it has to be on one of these slots. Right? Yeah, if we don't have a 5 in either of these circles, it's 3 and 7, which does not form a 4-length Renban. So 5 has to be one of these two 5s, which means this... We cannot have a 5 on this Renban. These 5s also both see this 5. So this can't be 5 here. They also both see a 5 there. So one of these 4 is going to be a 5. Okay, what happens in these situations? If this is 5, that means this is 7, which makes that... Okay, so this digit... we don't know. One of these is a 3. We're not sure which. So that's 2 3s taken care of. This must be 2 or 3 here. Which means we have a guaranteed 3 on this Renban. So it could be 3 through 8. Or it could be 1 and 2, right? We just don't know. 5 obviously cannot be here. We cannot have 9 there. 8 can't be here because we're guaranteed an 8 on this 3-length Renban with the 7. It could be 6, 7, 8 or 7, 8, 9. Whichever is 2 or 3 here, it cannot appear anymore in any circle. Because we already have a 3 guaranteed here, and then a 3 guaranteed in one of these two cells. So that's 2 3s already accounted for. And we have a 2 here, and then that would be the other 2. So this digit cannot appear in any other circles. So this is unique, but I don't know if that helps us with anything. 8, interesting. 8 cannot appear here. That means 8 either has to be on this Renban or it's here. Hmm. Hmm. Now this is interesting. What happens? Okay, what happens if this is 5? If this is 5, that becomes 7. That makes that 5 there. These can't be 5. So if we have 5 and 7 there, that forces us to be 5. Oh, that's interesting. Either this is 3 and 5, in which we have the other digits are 2, 3, 4, 5, or 3, 4, 5, 6. Or this is 5 and 7, in which case it's 4, 5, 6, 7, or it's 5, 6, 7, 8. So what are the combinations then? If this is 3 and 5, this has to be 2. This could be 2 or 4, or it's 4 and 6. If this is 5 and 7, we could have 4 and 6 here, or it's 6 and 8. Interesting. Again, if this were 5, that would force this to be 5. So one of these two is a 5. So say we make that a 5. If this is 5, that becomes 7. This is 5 there. So 5 cannot be here or here, which means 5 on this Renban would have to be here. 5 can't be here, here, or here. So 5 would have to be there. That would be interesting. So this would be then 7, that would be 5, that would be 3. Does that even work? We have 1, 5, 2, 3. 5 would eliminate 5 from being here. So we have 3 5s in that case. But this can't be 5. This can't be 5. And only one of these two can be 5. So we'd have 4 5s in, at most, in the circles, which is not allowed. So we know this can never be 5 here, which means 5 has to be here. That eliminates 5 in the rest of the column. So this is 5, which makes this a 7, which makes that a 5 here. It's 5, 6, and 7. This must be 5, 4, and 3. That eliminates 3 there, so that's 2. So no more 2 here. We have all the 2s then in circles. So that eliminates 2 here and 2 here. This has to be 1 through 6 or 2 through 7. There's no more 8 involved. So we have 3, 4, 5, 6 here. So this cannot be 3, 4, 5. Or also 5 and 6 eliminate 5 and 6 here. So no 5 here. 6 can't be here. Which means 5 is one of those 3. 6 is one of those 2. 5 being one of those 3 here eliminates 5 being here. So where's the 5 in column 3? It has to be here. So 5 is here, which means this can't be 5. 5, 6, and 7. We have to have 5 more 7s, and we have 2 5s here. One of these, that's 3. But if there's a 5 here, I think this is still problematic. If this is 5, that eliminates 5 here and here. Well, that's okay because then we could have 5 here and 5 there. So that's 1, 2, 3, 4, and we could have a 5 there. So that does kind of work. What happens if we have 5 here? If this is 5, that means this can't be 5 anymore. And this can't be 5, so one of these 3 is a 5. Obviously, 5 eliminates the 5 there, so this is 5. And we don't... This can't be 5 anymore. This could still be a 5, though. No, this can't be 5. So if we try to have a 5 here, that eliminates 5 from one of those two. So therefore, this must be 5 there. That eliminates 5 from being there. We have 1, 2, 3 5s in circles, but we could only have at most one more. So that doesn't work. So we know this can't be 5 here. We know in column 1, this has to be a 5. So that's 5. This can't be 3 or 4 anymore because of 3 or 4 in the column. We have 5 here, 5 here, 5 there. One of these two is a 5. That gives us 4 5s. 2 can no longer be in the... Aha. 2 can no longer be in the circles because we have 2 2s in the circles. We have a 3 guaranteed here. One of these is 3. And this is a 3, 5, 7 triplet, which guarantees a 3 in one of these circles here. That eliminates 2 and 3 in the rest of the circles. So this can't be 3, that's 7, which eliminates 7 there, so it's 5. This can't be 3, so that's 7. This is again 3, 5, 7. 5 eliminates 5 there, so it's 7, which means this can't be 7. Can't be 3, it's 5 there. So this cannot be 2 here. It's 4, 6, or 6, 8 here with the 5 and 8 there. So 6 is one of these two, which eliminates 6 in any of the cells that are seen by both of these cells. 7 eliminates 7 in the rest of the row. And we eliminate 1 in the rest of the row because we cannot have 1 through 7 as a 6-length Renban. Therefore, this must be 6 here. No 1 or 6, no 1 or 6 becomes a 3, 4 pair here. Remaining digits of row 1 then, we have 1, 2, 8, 9. Okay. This is 5 through 7 here. 1, 2, 8, 9. I don't know how I missed the whatever. On this Renban, we could have 2 through 7, 3 through 8, 4 through 9. So no 1 there. 5 cannot be here. 5 eliminates 5 here. And this can't be 5, so that's 7. This can't be 5 or 7 because we have a 7 on the Renban, 5 in the row, so that's 3, which makes this 7. That leaves a 5 there. This must be 3, 4, 5, 6, 7 then. How many 7s? We have 1, 2, 3, 4, 5, 6, 7 7s in circles. This has to be 3, 4, 5, 6, 7. So, and this cannot be 6 because it sees both of the 6s here. This 4, 6 pair eliminates 4 and 6 in the rest of the box, so this can't be 4 or 6. It's 8, which makes this a 5, 6, 7, 8 Renban. This can't be 6 because of 6 in the column, so that's 4 and 6 there. 6 eliminates 6 and 7. No more 7 here. 5 eliminates 5 there. 8 eliminates 8 there. So 8 has to be one of these two digits in this box 5. That eliminates 8 in the rest of the row, so this can't be 8. Where is the 8? Then on this Renban, it has to be here. That's 8, which makes that 9. That eliminates 9 in the rest of the column. This is 6 or 9. We still don't know which. 5 eliminates 5 in the rest of the row here. This is a 4, 8, 9 triplet, which eliminates 4, 8, 9 in the rest of the row. And box, this can't be 4 or 9, it's 5. This can't be 4, 8, nor 9, it's 6. So we have 6, 7, 8 there. Okay, this is a 5-length Renban. So it's either 3 through 7, 4 through 6, sorry, 3 through 7, 4 through 8, or 5 through 9. 6 and 8 cannot be here. Actually, we know there has to be a 6 somewhere here. 6 can't be here, 6 can't be here, so 6 has to be there. 4 cannot be either of these. So this cannot be 3 through 7 or 4 through 8. It has to be 5 through 9. So this has to be 8 or 9. 8 can't be here because of 8 in the row, so this is 9, which makes that 8. Remaining digits in box 7 are 1 through 4. No 4 in either of these cells. So we're guaranteed this can't be 2 or 3 because of 2 or 3 in the column, so that's 1, which eliminates 1 in the rest of the box. This is 2, 3, 4 as a triplet. We have 1, 9 as a pair remaining in column 3. Okay. Remaining digits of column 1, we have 7 and 8. 7 cannot be here because of 7 in the box, so this is 8, which makes this 7. We have a 1, 2, 9 triplet left in box 4, but this cannot be 9 because of the 4, 8, 9 triplet there, so the 9 has to be there. Remaining digits in box 1, we have 1, 3, 4, and 9 possible. Okay. Remaining digits of box 8, we have 1, 2, 3, and 9. 3 and 9 eliminate 3 and 9 here. No 3 there because of 3 in the row. No 2 here because of 2 in the column. 4 eliminates 4 in the column. One of these is a 9. We have 8 5s. We know where the last 5 has to be. It has to be there. 7s. We have 8 7s. We know where the last 7 has to be. It has to be there. 6s. We have, where is 6 in row 7? Cannot be here because of 6 in the box. Can't be here because 6 in the column. So 6 has to be there. That eliminates 6 from being here. So where is this Renban? Having a 6, it must be there. Okay. That gives us all the 6s. How does this work as a Renban? It could be 4 through 9, 3 through 8, or 2 through 7. So we have 3 or 4 here. It could be 4 through 9, 3 through 8, 2 through... If it's 2 through 7, this would be 2, and this would be a 3-4 pair. Okay. Remaining digits in column 7. We have 1, 2, 4, and 8. This can't be 4, 8 because of the 4, 8, 9 triplet in the row. This can't be 4 because one of these two has to have a 4 there. We have a 1, 2, 8, 9 quadruplet in box 3, which eliminates 1, 2, 8, 9 in the rest of the box, so this must be a 3-4 pair here. So either this is 2 with 3, 4, 5, 6, 7, or this is 8 with 3, 4, 5, 6, 7. So it cannot be 9. This is 2 or 8. We have a 1, 2, 8 triplet now. We also have a 1, 2, 8 triplet in box 3 and a 1, 2, 8 triplet in Column 7. So this can't be 1, 2, or 8. It's 4. Also, one of these is guaranteed. This 1, 2, 8 triplet eliminates 1, 2, 8 in the rest of the box. So it's 9. Where's the 1 in box 3? It must be one of these two. So this can't be 1. It's 2, which makes that 1. That means this can't be 1. That's 9, which makes that 2. 9 eliminates 9 there, so it's 1. There's no 1 here. 2 eliminates 2 here. It's a 1, 8 pair, which eliminates 1 and 8 in the rest of the box. So this can't be 1 or 8. It's 2. Therefore, no 2 there. And we have 2, 3, 4, 5, 6, 7 as a Renban. Same with this. And the rest is just normal Sudoku. Remaining digit in row 4 is a 3. That eliminates 3 there, so it's 4, which makes that 3. 4 eliminates 4 in the rest of the row, so it is 3. Remaining digits of row 6 are 1 and 8. So this is a 1, 8 pair. Remaining digits of row 7 are 1, 2, and 4. No 2 here because of 2 in the column. Remaining digits of row 8, we have 2, 3, and 9. This can't be 3 or 9 because of 3 or 9 in the column. That makes this a 2. So no 2 here. It's 3, which means this can't be 3. This can't be 2, 3. It has to be 9. Remaining digits of row 9, or specifically box 9, have to be 1, 4, and 8. No 4 here because of 4 in the column. Okay. Remaining digits of row 2. We have 3, 8, and 9. 8 cannot be here. We now have a 3, 9 pair in row 2, which eliminates 3, 8, and 3 and 9 in the rest of the row. So this can't be 3 or 9. It's 8. That makes this 9, which makes that 4, which makes that 8. 8 also eliminates 8 here, so that's 1, which makes this 8, which makes that 1. 1 eliminates 1 here, so it's 3 and 1. It also eliminates 1 here, so that's 2. No 1, 2, or 3 here. That makes that 9. No 1 here, no 9 here, no 2 here, so that's 3, which makes this 1. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 1. That makes this 8, which makes that 4. 1 eliminates 1 here, so it's 8 and 1. 3 eliminates 3 here. Ooh, we got a 3, 4 pair. That's really bad. How did I mess that up? Ugh. I messed it up somehow, though. One, two, three, 4, 5, 6, 7 circles. 1, 2, 3, 4, 5 circles. 1, 2, 3 circles. 2 circles. Ugh. How did I mess this up? Ugh. This is 8, 1 and 8, 1, no 1 here, it's 3, no 1 here, it's 2, 4 and 2, 4 eliminates 4 here, so it's 1, which makes that 8 and 1. We have 3, 4, 9 as a triplet here. How? Dang it. Ugh! How did I mess this up? That means we have to have 2 here. We're missing a 6. Oh. Dang it. Oh, 8 eliminates 8 here, so that's 1 and 8, which makes that not 8, that's 1. Makes that 3 and 1, that makes that 2, 4 and 2. We still have the same problem. That's 9. 3, 4, 3, 9, 4. 4 makes that 9. 2 and 6 can't be here. What the heck? How did I mess this up? Ugh. Hmm. Hmm. Uh. Okay. Let's clear everything else up. This has to be 5, 6, 7, 4, 4, 3. We have to have 5 here. 5 cannot be here, so 5 has to be there. No 5 here. Um, 5 is here, which makes that 7. So therefore, this is 3. 4, 6 as a pair. This can't be 4, 6. It's 8, 5, 6, 7, 8. So that's 6, which makes this 4 and 6. 5 can't be here. 5 has to be here. This is 4, 8, 9. No 8. No 4. This can't be 8 or 9. It's 6, which makes that 8, which makes that 9. 3 eliminates 3 here. It's 7. 7 in column 1 has to be there. 4 cannot be here. 4 cannot be... This could have been 4. 6 can't be here or here, but we would need a 6. So that's 6, which means this can't be 4. This does have to be 8 and 9, so that's 9 and 8. We have 8 sevens. The last 7's there. We have 8 5s. Actually, we have 9 5s. 6 is one of those two, so 6 has to be there. We have 8 6s, or actually, we know 6 cannot be here because of 6s in the boxes. 6 can't be here, so 6 is there. That eliminates 6 there, so 6 has to be there. That gives us all 9 6s. We have 1, 2, 3 remaining. 1, 2, 1, 2, that's 3. Oh. No. 1, 2, 4, and 8. 4 guaranteed has to be there. So this can't be 4, so 4 has to be there. 1, 2, and 8. 8 has to be one of these two. Oh, maybe that was the mistake. We need a 5 somewhere here. Cannot be on... Okay, never mind. We have 8 5s, so the last 5 is there. Which means this is a 3-4 pair. Could be 2 and 8. That's the same problem, so that's 9. Shoot. 1, 2, and 8 here. 1, 2, and 9. 1, 2, 3, 4. No 2, 3, or 4 here. It's 1, which leaves this as an 8. No 1 here. It's 2, 3, 4. So no 2 here. It's 1 and 9. It's the same problem. How did I mess this up? We have 1, 2, 3, 4, 5, 6, 7 sevens in circles. We have 5 5s, 2, 3, 4, 5 5s in circles. We should have 3 3s, 1, 2, and one of these is 3. We have 2 2s, we have a 1. How did I mess this up? Okay. Ugh. No 3, no 2. Oops. No 3, no 4. This is 2, 3, and 9. No 3 or 9 here. It's 2. That eliminates 2 here, so it's 3. No 3 here, so this is 9. This is really bad. How did I mess... I don't see how I messed it up this badly. 3 eliminates 3 here, so it's 4 and 3. 2 eliminates 2 here. 4 eliminates 4 there. Shoot. How did I screw this up? Three eliminates 3 here. So that's 1, which makes this 3. No 3 here. 9 eliminates 9 there. It's 4, which makes that not 4. It's 3, 4. 1, 9 as a pair, so that's 3. This can't be 3 or 4. 1 eliminates 1 there, so that's 9. Which makes this 1, which makes that 9. 3 eliminates 3 there. It's 1 and 3. It's no 1 or 9. It's 2. That makes this not 2. It's 1, which makes that 9. 2 eliminates 2 here, so it's 4 and 2. 1 eliminates 1 here, so it's 4. No 4 and 9 here. It's 8. 1 and 8 eliminate 1 and 8 here. It's 2, which makes this 8. But then we don't have an 8 anywhere in column 7. How did I mess this up? This is so bad. I don't know how I screwed this up so badly. Jeez. What am I doing wrong here? Okay, we need to just restart. Okay. One, two, three, four, eight. Again, we can't have two, three, four here. That would require one to be one of these. And then one can only be with a one, two, three on the Renban, but two, three, and four are already eliminated. So if it's one, two, three, four, eight, we have one, two, three here. We have four here and eight here. Eight, though, is not three or more, fewer away from four through one. So cannot be one, two, three, four there. So if we try one, two, four, five, six, again, we still have the same. Oh, this doesn't have to be a two. I don't know why I did that. That was bad. Okay. I don't know why. I just okay. Yeah. One. So this is all correct. This is still. I don't know how I got that as a two. Ugh. That's pretty bad. This is 5 and 7. Um, we have 1, 2, 3, 5, 7 here. Again, 3, 5, and 7. 3, 5, and 7. This becomes a 4, 6 pair. If it's 3, it has to be with 5, and that's 4. If it's 5, 7 as a pair, 6 has to be here, so it's 8 and 9. 8 and 9, so everything else is correct. I don't know why I kept thinking the 2 had to be in between. Maybe it looks kind of like Kropke dots a little bit. And that's what was throwing my mind off. Anyways, okay. And then this is the same logic if this is 5. Because the 2 doesn't affect anything here, right? So again, one of these is 5 here. One of these is 5 here. We have one of these being 5 here, which means we have to have a 5 be one of those two. Right, it doesn't have to have a 2 there. Probably people were yelling at me, why is there a 2 there all the whole time? So apologies for that. This again could be, it's 5 or 7, which is 3, 5, or 7 there. We have 4 and 6. We could have 2 here. We could have 8 here, 8 here. Why was this? Okay, this couldn't be 5. It can't be 7, so this is 2 or 3 here. Which means this is 2, 3, 5, 7. So we're guaranteed 4 is here, 5 is here, 6 is here. So 5 cannot be here. 5 is one of these. 5. We try to have a 5 here, and I think that led to a contradiction, right? 5 there, 7 there. So if we have 5 there, that's 7. This must be 5 for this to form a Renban. 5 cannot be any of these 4 digits, so it must be there. So 5 cannot be there, which makes that 5. 5 eliminates 5 from being here. Only one of these two. So this 5 makes this 7, which makes this 5, and that's 3. 5 is only... 5 cannot be in the circle. 5 is only in 3 circles. It can only be in one of those, so therefore that's a contradiction. So this can't be 5, which means 5 has to be there, which makes that 7, and 5. That's 6, 5, 5, 6, 7. So it's 4, 5, and 3 to be valid, so that makes that 2. Therefore, this can't be 2 here. We have 3 remaining here. We don't have 2 available. This becomes a 3, 5, 7 triplet. 5 eliminates 5 here. We tried having 5 there. We had the same this can't be 5 because of a 3, 5, 7 triplet actually in the row. So 5 has to be here. We have 1, 2, 3. This can't be 5 anymore. That means 5 is one of these 3, which means this can't be 5. Which means where's the 5 in column 3? It must be there. That means this can't be 5. We already have all the 3s available in circles, so this can't be 3, it's 7. No more 3 here. This can't be 5, so that's 7, which makes that 5 there because it can't be 3 anymore. 5 eliminates 5 there. 7, so this is 5 there, which means this can't be 5. This can't be 3 because we already have 3's accounted for, so this must be 7, which makes that 3, which makes that 5, which makes this a 4, 6 pair. This can no longer be 2, it's 5, 6, 7, 8, or 4, 5, 6, 7. Can't be 4 or 6, so this is 8, which makes that 6, which makes that 4 and 6. And we have the same logic. This has to be 6, this has to be 8 and 9. This can't be 1, 2, or 1, 2, 3, 2, 3, or 4, so that's 1, which makes that 2, 3, 4 there. 5 can't be here, 5 has to be here, which forces this to be 4, 8, and 9 as a triplet. No 4 here, no 8 here. This can't be 8 or 9. That leaves that as a 6, which makes that 8, which makes that 9. We just have a 1, 9 pair left here. This has to be 6. 7 can't be here, so 7's there. That makes that 8. This becomes a 3, 4, 3, 4 pair. 1, 2, 8, 9. No 9 here. What do we have here? We have 1, 2. Cannot be 3. This can't be 3, so 3 has to be here. That's 1, 2, 1, 2, 1, 2, and 9. This is 1, 3, 4, and 9. 6 has to be one of these two. This has to be, okay, 7s. The last 7 is there. Ugh, this was really bad. I don't know why I put the 2 there. I just left it there. 5, we have 8 5s. The last 5 is there. No 1 here. 4 is 1 on these. How did we get 6 there? Oh yeah, 6 can't be here. Can't be here because of 6 in the box, so 6 has to be there, which makes that 6 there. It has to be on the Renban. 4 is one of these two, so 4 cannot be here, so 4 has to be there. This is 1, 2, and 8. Okay, this is 3, 4 as a pair. 3 eliminates 3 here, so this is 4, which makes that 3. No 4 here, no 3 here. Okay. 3 eliminates 3 here, no 4 here. This can't be 3, 4, 5, 6, 7, so this cannot be 9. We have 1, 2, 8 as a triplet. That eliminates 1, 2, 8 in the rest of the box, so that's 9. 1 has to be one of these two, so this can't be 1. That's 2, which makes this 1, which makes this 9, which makes that 2. No 1s here. 9 eliminates 9 here, so it's 1. No more 2s here. This is 1 and 8, which forces this to be 2, so no 2 or 9 there. It's 1 or 8. We have 1, 8 here. Let's be 1, 2. 1, 2, or 4. No 2 here because of 2 in the column. Again, 2, 3, and 9 here. This can't be 3 or 9, so this must be 2, which makes this 3. No 3 here. It makes that 9. This is 1, 4, and 8. No 4 here. Okay. This is, we have to have an 8 somewhere in row 2. 8 can't be here because of 8 in the column, so this is 8. This becomes a 3, 9 pair. We have a 3, 4, 9 triplet in column 4, which eliminates 3, 4, 9 in the rest of the column. No 3 here. We need a 6 somewhere, so this must be 6 there. That gives us 9 6s. That leaves this as 1 or 2. That means we have a 3, 9 pair here. 8 eliminates 8 here, so that's 1, which means this can't be 1, that's 2. This can't be 2, that's 4, which makes that 2. 4 eliminates 4 here, so that's 1, which eliminates 1 here, so it's 8 and 1. This can't be 1 or 2 because of 1 or 2 in the column, so that's 3, which makes this 9. 2 eliminates 2 here, so that's 1, which eliminates 1 there, so that's 2. This can't be 2 or 3, it's 1. 9 eliminates 9 there, so it's 3. 8 eliminates 8 there, so it's 9, which makes this 4, which makes that 3, which makes that 9. No 4 and 9 there, it's 8. That leaves this as a 2, and this as a 4. 4 eliminates 4 here, so it's 9 and 3, which makes that 4. 1 eliminates 1 here, so it's 8 and 1. 1 eliminates 1 here, so that's 8 and 4. And if I hadn't put the stupid 2 in the middle, I don't know. I think I just saw it as white crop key dots for some reason because of all the white circles. And I think that triggered in my brain that those were white crop key dots. I don't know. I don't know how I basically got to that. That's my guess though of what happened there. Obviously it's a Renban, so it shouldn't have to be, the 2 shouldn't have to be in the middle. But I think I just saw too many white circles, and then for some reason that triggered. Well, I mean, it makes sense. See white circles, you see, oh, white crop key dot, right? I don't know. Anyways, hopefully you didn't struggle like I did through this. And if you did, go with me all the way through this. Thank you for watching the whole way through and watching me struggle and be just, well, kind of an idiot in trying to solve this. Anyways, either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.